All right, so this first one, you end up with those x-intercepts and the y-intercept just from getting it from the calculator. And when it asks how many times did it change direction, that's like it's decreasing and it changes to increasing, or vice versa. So that's once. And then the factors are related, just they're basically just kind of opposites. All right, this next one had a little bit more going on. And so on D, it asks, what is different about the behavior at x equals 2 and x equals negative 2? So x equals 2, it goes straight, or x equals negative 2, it goes straight through, just regular. But it bounces, the graph bounces at x equals 2. Why do you think that is? Like, what parts of that make it bounce? It's because there's two of them. It's squared. So when there are two, it's like the quantity x minus 2 quantity squared. It kind of acts like a quadratic at the x-axis. It acts like a little parabola because it kind of is following that same behavior. So here it's going to bounce because that factor is repeated twice. Do you remember what that was called in Algebra 2? Anybody? It was something I would guess you kind of struggled with because it's the first time you saw it. It's called multiplicity. It's not maximum minimum. That's a different idea. It does create a local minimum, yes. But it has a multiplicity of 2. When that happens, it means there's two factors. And at that, x-intercept is going to bounce. And then why do you think that happens? We could say there's two factors, and it acts kind of like a quadratic. Right, and then on the last one, we have three factors. So x minus 2 is repeated 3 times, and so it acts differently. It does go straight through, but I wrote that it hangs out a little longer at x equals 2, or we could say it bends. And so, do you guys remember what the cubic parent function looked like? It kind of looks like this right here without being wobbly like that. So whenever it's a factor being cubed or multiplied by itself 3 times, at the x-axis, it kind of acts like a cubic. All right, so you guys can go back to your seats. We're going to do the notes on the other side. And there's a lot of stuff we're going to learn about polynomials. This is just like the very, very beginning. But we've learned enough to get halfway decent graphs in certain situations. But we're going to learn a lot more. Okay, so some important ideas is that polynomial functions have positive integer powers. So you're not going to have any negative exponents on your x. You're not going to have any fractional or decimal exponents on your x. It's going to be like x squared plus x cubed plus x, like just normal, regular integer numbers. All right, and one thing I want you to know about the graphs is that the graphs have smooth, rounded turns. So as you graph these, they're not going to have any like jagged edges. Everything is going to be smooth, rounded. Okay, so the main thing we're going to talk about today are x-intercepts, y-intercepts, and multiplicity. So the x-intercepts are where the function equals 0. Sometimes those are also called zeros of the graph, and we'll talk more about that tomorrow. But when we're finding x-intercepts, you set the factors equal to 0 and solve. Now, pretty much we just do that in our head like we did on the other side. It's just going to be the opposite of what's added to x. Right? For the y-intercepts, that's f of 0, or you're going to plug 0 in for x and solve for y. Or find y. It's not really solving, it's just multiplying things together. Okay, and then the multiplicity of a factor is the number, or of a 0, is the number of times a factor occurs. All right, so for this k, or x minus p raised to the k, which is going to be the 0, the p or the k, or the x-intercept? P or k? P. So we would say p is a 0 because it makes the function 0 with multiplicity k. And anytime that k is odd, then the graph passes through at that 0. Now, if k is 1, it passes through like a line. It just goes straight through. Nothing weird happens there. If k is 3, it passes through like a cubic. So you'll be going, and then it bends and then continues going. Right. And then when k is even, this is when it bounces at the x-axis. All right. So coming up, it has a 0 or x-intercept, and then it bounces back like a parabola right there. Okay, so let's look at our check for understanding questions. For number 1, we have a graph of a polynomial, and we want to know which of the following could be the factored form of the function. So let's just start off with the x-intercepts. So this one has 3 x-intercepts at -3, -1, and 4. So what 2 choices can we just mark out that they have the wrong x-intercepts? A and C, right? Because we do the opposite. So if the factor is x minus 3, the 0 or x-intercept would be positive 3. So we want -3. So for D and B, those work, right? And the only other thing we know right now is the y-intercepts. So we need to figure out if B or D has the right y-intercept. So for the y-intercept, we're going to find f of 0. So we'll put 0 in for all of these x's. So we end up getting 3 times 1 times negative 4, which is negative 12. Is that the right y-intercept? What y-intercept do we want? 2, so that's wrong. So it's B, but let's just double check on the y-intercept. So this time it's negative 6 times 3 times 1 times negative 4. So negative 6, bless you, times negative 1 6 times negative 12 is 2, which is what we wanted. Now we're going to learn some things about in behavior tomorrow that will also help us narrow down our choices. Okay. And then for number 2, they ask us to find the C and T intercepts. So same as x and y, except this function doesn't have x and y, it has C and T. So what we would normally do to find the x-intercepts, that's going to be the t-intercept. I did notice in your book, sometimes it'll say vertical and horizontal intercepts instead of x and y, but they all kind of mean the same thing. All right, so before I can find my t-intercepts, what do I need to do? Yeah, we need to factor it. And so first thing we would do to factor it is factor out a common factor. It's been a while since we factored. All right, and then that's going to be T and T. And then if this is a plus, it tells you the signs are the same and they're both going to be minuses. And then we want to multiply to get 3 and add to get 4. The only options are 3 and 1, and they work. So what are our t-intercepts? There's one more. And 0. So if a factor has a t, it's going to give you a t-intercept. So 2t squared gives you an intercept of 0. It's really whatever makes the factor 0. All right, and then for the c-intercept, we're going to find c of 0. So put 0 in for all the t's. Sorry, that should be positive 3. And that's going to be 0. All right, any questions? We could have hit 0 in for all the t's at the beginning. That would actually be easier. And it's also in standard form there. So when the function's in standard form, the constant gives you the y-intercept. You guys remember that from quadratics? And so if there's nothing there, it is 0. Okay. And then this last one, we're going to do a sketch. Even though we're only talking about x and y intercepts, we can get a halfway decent sketch here. All right. So this function has 2 x-intercepts, 1 and negative 3. What is the multiplicity of 1? Is whatever that power is. However many times the factor is repeated, that is the multiplicity. So it has a multiplicity of 3. So it is going to pass through on the x-axis, but it's going to bend. It's going to have a little squiggle right there. All right, and then the multiplicity of negative 3 is going to be 2. And what is it going to do at the x-axis? It's going to bounce. All right. And then the other thing we're finding today is the y-intercept. So we would find h of 0 by putting 0 in for all of your x's. So what is negative 1 cubed? Close. Negative 1. So 3 negatives make a negative when you're multiplying. All right, so our y-intercept needs to be negative 9. All right, I'm going to start off. I'm going to graph those intercepts. Now, I don't know about like relative min and relative max values using these. So I do know that I'm going to come through cross, and it might go lower. That might be the most low. I'm just going to write it like that. It'll be fine. It's just a sketch. Doesn't have to be perfect. All right, so I'm going to continue my graph to the left so I can make sure I cross or I touch the x-axis when x is negative 3. But once I get there, what am I going to do? I'm just going to bounce back down. So I'm going to just touch it and bounce back down. And then it's going to continue going down because it can't curve back up because it's not going to touch the x-axis again. Okay, and then going to the right from the y-intercept, I am going to cross when x is 1, but I'm going to bend. There it is. That's a decent graph for that function. All right, so what questions do you guys have about polynomial? We're going to learn a lot more. There's a lot more to polynomial. All right, your assignment is kind of short. I actually have taken some off of it because we're not quite ready for them yet. But what I want you to do on on that page, which I posted in Google Classroom, is 2 through 6 even, and then 14 and 16.